All right, today we're doing a deep dive on a single piece of hardware with a name that, well, it sounds straight out of a classified inventory.
Uh,
E-SER-2FOMMSC.
it definitely has that ring to it.
It does. So our mission is to cut through that jargon. We want to figure out what this NTI RS485 232 to fiber converter extender actually is.
And why it even exists.
Exactly. Why these decades-old protocols still matter and what these specs tell us about where this thing is built to survive. So, okay, let's unpack this.
Well, at its heart, this device is a bridge, a really critical one. You have to understand, so much of the world's most important infrastructure, it runs on these super reliable, legacy RS communication standards.
Right. This stuff that just works.
It just works. And this converter lets those really robust, older sensor systems talk to modern fiber optic networks. And you absolutely need that for dependable long-distance data transmission in places where failure is not an option.
So if you strip away the name, its core job is just pure conversion.
Yeah.
Takes data from one of those three RS protocols.
Yep, the electrical signal.
And turns it into light to send it over fiber. And it specifically connects that standard copper cabling your RJ45 runs to the fiber on both ends of the connection.
And the number one reason it exists is distance. I mean, that's the whole ballgame here.
The reach.
The reach is fascinating. You use a duplex multimode SC cable, either 50 or 62.5 micron, and this thing extends your signal up to 1.2 miles. That's 2 kilometers.
2 kilometers. That's a serious range.
It is, and fiber handles that effortlessly.
That does raise a question, though. I mean, that reach is huge. But doesn't running fiber add a lot of complexity? Why not just use, I don't know, powerful line drivers on some really high-quality copper?
Because copper just dies at that distance. It can't do it. Even the best cable runs are really limited. It depends on the sensor, of course.
Right.
But the total combined length, local and remote, can't go over 1,000 feet.
It's about 300 meters.
Right. So if your monitoring point is half a mile away, fiber conversion is pretty much your only robust low latency option. Plus, look, they built in surge and static protection.
Which tells you something.
It tells you this gear's designed for places where you can't trust the power or the environment.
Speaking of environment,
Yeah.
let's talk about the physical side. You're looking at 2 SE fiber connectors, and they position terminal block for the RS connections and a little two-way block for power. It comes with a couple of power supply options, too.
The 12 VDC and 5 VDC units, yeah.
And it also says it's TAA compliant. Now, for people who aren't familiar, is that just a government procurement thing, or does it tell us something specific about where this gear ends up?
Oh, that's a huge operational clue. TAA compliance means it's made in a friendly country, basically. So it's very likely being used in critical government-funded projects, utility grids, maybe defense systems. This is not your standard commercial hardware.
That makes perfect sense when you see the temperature rating. I mean, this really raises a question. What kind of sensor has to work across these massive temperature swings? This device is rated for a truly extreme environment.
It really is.
It goes from a frigid -40 Fahrenheit all the way up to a blistering 185 degrees. That's -40 to 85 Celsius.
That range just screams remote industrial control. Think oil and gas pipelines out in the desert or maybe extreme weather monitoring stations in the Arctic.
Right.
And the documentation confirms it. It connects this device directly to NTI's EnviroUX units. So it's feeding critical data tank levels, pressure readings, you name it, back to a command center from a huge spread out area. And of course, it has all the approvals. CE, FCC, RO, HS.
So if we boil it all down, what are we looking at? The E-SER-2FOMMSC is basically the ultimate bulletproof adapter.
That's a good way to put it.
It's a very specific TAA-compliant tool. It's designed to take these tough but distance-limited legacy protocols and just shove them over incredible distances, like 1.2 miles,
Yeah.
in extreme temperatures, all to keep critical monitoring systems like the EnviroUX network online.
And if you connect that to the bigger picture, it's not just solving a distance problem. It's really a testament to the idea that when you need extreme reliability, sometimes a 40-year-old protocol is better than the bleeding edge.
Simplicity and reliability.
Exactly. This kind of specialized conversion tech is the silent hero making sure these old, tough sensor systems can use the speed and resilience of fiber to keep our critical infrastructure running.
So think about that. All the pieces of our world traffic systems, environmental sensors, power grids that rely on these old data protocols just being converted to fiber so they can survive the distance and the elements. It makes you wonder, what other legacy systems do you think are secretly running the world?